Section 6.6, Graphing Linear Equations. The Cartesian coordinate system. This is the system where we plot points and we plot lines and functions. The horizontal line is called the x-axis, which we see right here. And the vertical line is called the y-axis. We notice that the Cartesian coordinate system is divided into 4 quadrants by those axes, and the point of the intersection of the two axes is called the origin. Each point in this xy plane corresponds to a unique ordered pair a comma b. So for instance, if we look at this point right here, 5, 3, if we want to plot that point, we start at the origin. The first direction we move is horizontally, which is the x direction. We move 5 units to the right, and then we move vertically, which is the y direction, and we move 3 units up. Identify the coordinates and the quadrant for the 2 points shown on the graph. So for point C, again, we start at the origin. We're going to move horizontally first. We're going over to -3, and then we're going to go up to 5. So the point's coordinates are -3, 5. The quadrant is, remember, we start numbering with quadrant 1, 2, 3, and 4. So this is quadrant number 2. Point D, start at the origin. We move horizontally first. We're going to move 3 units to the right, so that's 3, and then we go down 3 units, so that's -3. So the coordinates of point D are 3, -3. The quadrant is quadrant number 4. Determine which ordered pairs satisfy the given equation. You have a problem like this in your homework, and they're going to give you an equation, and then they're going to give you 3 ordered pairs and say which of those satisfy the equation. There could be 1, 2, 3, or none. So what you're going to do is take each ordered pair, and if the ordered pair satisfies the equation, when we substitute the values, we'll get a true statement. So I'm going to take first the ordered pair 10, 2, and I'm going to replace x with 10 and y with 2. And I've done that right here. And I notice when I come down here, I come out with an 18 on both sides, which is a true statement. So therefore 10, 2 satisfies that equation, and it's a solution. And now we're going to try the point 2, 4. So I'm going to replace x with 2, and I'm going to replace y with 4. And again, I come up down here, and I get a true statement. So therefore this is a solution, and that ordered pair satisfies that equation. And then finally, let's try the ordered pair 0, -2. And I've done that over here, and I notice the last thing I come down to is -16, which does not equal 18. So therefore that ordered pair is not a solution. It does not satisfy that equation. And so I have 2 correct answers here. Let's talk about graphing linear equations by plotting points. So a graph is an illustration of all the points whose coordinates satisfy an equation. All equations of the form ax plus by equals c, where a is not equal to 0 and b is not equal to 0, will be straight lines when they are graphed. Now, such equations are called linear equations in 2 variables. Since only 2 points are needed to draw a line, only 2 points are needed to graph a linear equation. However, we usually also do a third point as what we call a checkpoint. If no error has been made, then all 3 points will be on the line, and they're called collinear. So if we wanted to graph the function or the equation y equals 2x plus 2, we pick some values for x. And here you can pick values that you want to pick. So I'm going to pick 0, 1, and -1. I take that value of x, substitute it into the equation, and solve for y, and these are the y values that I get. And I've got 3 points here that I can graph. And if I notice, here's my 0, 2 point right here. Here's my 1, 4 point right here. And then my third checkpoint would be here, 0, -1. And notice where the line crosses the axis is called an intercept. So this is the y-intercept where the line crosses the y-axis, and that coordinate is 0, 2. And this is where the line crosses the x-axis, and the coordinates of that point are -1, 0. And we can use those intercepts to do the graphing. The point, again, where the line crosses the x-axis is called the x-intercept. The point where the line crosses the y-axis is called the y-intercept. To find the x-intercept, set y equal to 0 and solve for x. And to find the y-intercept, set x equal to 0 and solve the equation for y. So we want to graph this equation, 2x plus 3y equals 6, by using the x and the y-intercepts. So first I'm going to find the x-intercept, so I'm going to let y equal 0 and solve for x. So I replaced y with a 0. And I have 2x equals 6, so x equals 3. So my x-intercept is 3, 0. And then I'm going to find the y-intercept. I'm going to set x equal to 0 and solve for y. And I come up with y equals to 2. So my y-intercept is 0, 2. And so now I have 2 points. And we're also going to do a checkpoint. I'm going to let x equal -3 in that equation and solve for y. So when I put in -3 for x, I'll go through my steps down here and solve for y. I get 4. So the point -3, 4 is my checkpoint. I want to make sure that I've done my work correctly. That point should also be on the line. So here's my two intercepts, 3, 0 and 0, 2. I would plot those 2 points and draw the straight line connecting them. And then I also check to make sure my checkpoint falls on that line, and indeed it does. The point -3, 4 is on that line. Now the slope of the line is a measure of the steepness of the line. It's the ratio of the vertical change to the horizontal change for any 2 points on the line. Many students learn this as rise over run, vertical change over horizontal change. If we take 2 points on the line, we take the difference in the y coordinates divided by the difference in the x coordinates. And there's 3 different ways it can be written. And again, you may remember it as slope equals rise over run, rise being the change in the vertical change over the horizontal change. Positive slope, as x increases, y increases. Negative slope, as x increases, y decreases. And a horizontal line, which neither rises or falls, has a slope of 0. A vertical line is undefined slope. Find the slope of the line that goes through the 2 points, -3, and 1, 5. So I'm going to use that slope formula. I'm going to take the difference in the y coordinates, and notice that whatever point I start with up top here has got to be the same x coordinate in the denominator. So I'm going to let this be 1, 5 be 0.2, and this be 0.1. So I've got 5 minus -3 over 1 minus -1. I go ahead and simplify that. I get 5 plus 3 over 2. 8 over 2 is 4. So the slope of the line that connects those 2 points is 4. It means there's a vertical change of 4 units for each horizontal change of 1 unit. As x goes up by 1, y goes up by 4. The slope is positive. The line rises from left to right. And here's that line graphed actually. And this is the 2 points, couple points on the line graphed here. Oh, these were the 2 points they gave us, -1, -3, and 1, 5. And if we notice over here, we can go from one point to another using that change of 4 units. So if I start at this point here, go up 4 over 1, there's my rise, there's my run. Oh, go back. And I can go from this point, my rise is 4 and my run is 1, and I get to the second point that I had on my line. And this is what we call the slope-intercept form of an equation of a line, y equals mx plus b, where m is the slope of the line and 0, b is the y-intercept of the line. Notice that the y-intercept is not just a single number. It has to be an ordered pair, and x is always equal to 0 in the y-intercept. So 2 parts for this one. We have an equation 4x minus 3y equals 9. And we want to write that in slope-intercept form, and then we want to graph the equation. So to write this in slope-intercept form, we need to rearrange the equation so that y is on one side and the rest of the equation is on the other side. And so I've chosen to keep the y term on the left side. So the first thing I'm going to do is subtract 4x from both sides. And I have this right down here, -3y equals -4x plus 9. I need to have a coefficient of 1 on y, so I'm going to divide both sides by -3. So over here I get y, and on the right side I get -4 over -3, which gives me positive 4/3 x minus, because I've got a -9 over 3 gives me 3. So there it is in slope-intercept form. Here's my slope, 4/3. And my y-intercept is 0, -3. Now I can graph this simply by using the slope and the y-intercept. I could find points on the line, but I can just use the slope and the y-intercept. So I plot the y-intercept, which was 0, -3, which is right here. And then my slope was 4 over 3. So I go up 4 units over 3. And there's another point on my line, which would be 3, 1. And I could go ahead and substitute that into the equation and make sure that point satisfies the equation. If I wanted another point on the line, I could go up 4 and over 3 to find another point on the line. Now, if I give you a line, an equation, graph of a line, can you find the equation? Well, we can do that because we can tell right here what the y-intercept is, and we can also tell what the slope is. So we know that the y-intercept there is 0, 1, so we then know that b equals 1, and then we can determine the slope from the graph. So the rise here to get to this point would be actually -1, and the run would be 3, so the slope of this is actually -1/3, and so therefore I can write the equation of this line. It's -1/3 plus 1. And I did that simply by looking at the equation, or the graph of the equation. And there's the equation of that line. And then let's do some horizontal and vertical lines. So in the Cartesian coordinate system, graph the line y equals 2. Okay, that's going to be a horizontal line. Any graph line equation of the form y equals a number is going to be a horizontal line. And then the second one, when it's x equals -3, it's going to be a vertical line. And dependent variable, independent variable. In graphing equations in this section, we label the horizontal axis as x and the vertical as y. For each equation, we can determine values for y by substituting values for x. Since the value of y depends on the value of x, we refer to y as the dependent variable and x as the independent variable. We label the vertical axis with the dependent variable and the horizontal with the independent. And when we get to the section 6.10 next week, you'll see that sometimes we don't use x and y. Sometimes, in fact, in the next example, you're going to see sometimes we don't use x and y. This is an example similar to one you'll see in your homework. Ryan sells chocolate on the internet. His monthly profit, P, in dollars can be estimated by P equals 15n minus 300, where n is the number of dozens of chocolates he sells in 1 month. So we don't have x and y this time, we have we have n and p. So first thing we want to do is graph this. So in order to graph it, we see that the slope is 15, that's the cost per dozen. We have a y-intercept of 0, -300. And so here's a graph of that particular equation. And again, there's some points labeled on here for you, but this is what the graph would look like. And we're looking at the profits based on the dozens of chocolates that Ryan sells. Now we want to estimate the profit if Ryan sells 40 dozen chocolates in a month. To find that profit, you want to let n equal 40 in the profit equation. So I went ahead and I substituted 40 for n, and I come up with he has a profit of $300. And we can actually go back and verify this on the graph. So if we look at the 40 here and we go up and look at where that crosses to the line there, it crosses at 300, which is what we found when we did the solution in the equation. And then we want to know how many dozen chocolates does he have to sell to break even. So break even means no profit, means profit is 0. So I'm going to let p equal 0 and solve for n. And when I do that, I come up with 20 dozen chocolates. So if he sells 20 dozen chocolates, he'll break even. And again, I can verify that on the graph here. And if you look here, when you have 20 dozens, it's actually crossing over. That's the x-intercept, and that would be his break-even point.